All right, we're live. We're back. What's up, everyone? My name is Sunny Ray. This is the Sunny Ray Show. Today should be an interesting one. I've got Nicola. Nicola, where did you say you're calling in from?
This is my home because it's kind of a holiday today, but
Yes, that's
Mountain View.
right. Mountain View. Amazing, amazing. Sunny California. So, Deep Infra. What are you guys working on at Deep Infra? Maybe we'll keep it to a couple paragraphs for now, but then we'll come back to it kind of near the last third of the interview. But thought we'd kick it off there.
Yeah, Deep Infra is a AI inference cloud. We help companies get access to the latest open source AI models hosted on our infrastructure. We really believe in open source AI models, and they offer a great price, I think, and very compelling performance. So we just love running AI on our clusters.
So maybe can you expand a little bit more? So which open source models? All of them, pretty much. All the big ones that I guess people are aware
Yeah.
of, like Llama and DeepSeek, but
So
yeah, can you talk a little bit more about that?
if I want to expand more, like we have a serverless option for many of the best open source models. We have around 190 models available on our platform. So you can access these models in like paper token, like paper request kind of fashion without dedicated like compute resources behind them. And then we also have like private dedicated models. So if like, your company needs a lot of tokens for, let's say, DeepSeek, then we can run like a private version of DeepSeek that's just for you. That then you can also fine tune and modify the weights of to get even kind of higher level of performance. I think the key thing about us is like we're really focused on inference. Like we're building a a cloud that's specialized at inference, and we kind of own and operate our own chips, our own GPUs, which we believe it's kind of the way to build this in the right way.
Fascinating. Oh my god, I can't wait to dig into that more. But Nicola, I always find that I don't know, talking about like the tech and the money and the business, all that stuff falls a bit flat unless you know a little bit more about the person behind all these projects. So Sophia High School of Mathematics is one of the most competitive math programs in Europe. What drew you in as a kid, and what was that environment like, kind of like day to day?
Yeah, it was kind of a bit of a chance in some way. I really liked math as a kid, like first, second grade. I remember the following story. Like my mom signed up my sister for like art lessons, and she asked me like, "What do you want to take extra lessons in?" And I was like, I thought about all the subjects at school, and I'm like, I guess math is like uh, the one that I like the most. And so she signed me up for extra math lessons, and then eventually I kind of you have to take an exam to kind of get into the school. And so once I got in, then I understood like how competitive the school was. Like before that, in my kind of neighborhood school, I was like number one in like math. But once you get into that school, you're like surrounded by all these other kids who are really good at math, and so you have to kind of work harder to be like good at it. And the school is really the top one in Bulgaria, I think, for like science and math. Like typically the national team of Bulgaria in both like the math and the informatics, which is the computer science Olympiad, a good portion of the team comes from our school. Um, it was a great kind of change. I think like getting to the right school and studying with the right people really helps. Also, I wouldn't have learned how to program as well if I hadn't had to kind of work together with some of my classmates who are like also into this, and then we kind of feed it off each other. Like they did some problems, I did some problems. Like we were doing the United States USACO, the United States Computing Olympiad. It's kind of a training program for the US team for the I guess the informatics Olympiad. But it was like an open program that you can participate in from Bulgaria, and that was kind of a key part of my upbringing.
I've got a future mathematician over here who wants to be a part of this interview. He does make special appearances. His name is Danny. Hey, Nicola, I was actually going to ask you about that. So, Bulgaria has produced an outsized number of top engineers globally. Just give me 1 second. So I was just going to ask you, what is it about the way math and computer science gets taught that that you think that the rest of the world misses?
I feel like the way we studied math in my school and in Bulgaria in general is like we had to kind of think and find like a proof to a problem, and I feel in the US more often people are just given like, here's how you solve this type of problems, now just like solve 5 others that are kind of like this one. I felt that there was less kind of room for creativity or like kind of going after complicated problems, as there was more like this just and I only saw like the US system in university, but I didn't think that it had as much kind of this more creative problems. And I think just as a former kind of communist country, Bulgaria always like emphasized like education and math and science. And so at least in school, this was always kind of emphasized to us. Like, we could skip like art class if we wanted to do extra math problems. And so
yeah,
Bulgaria has done quite well. Like for our size, like we're about like 6-7 million people. We always kind of are somewhere in the top 10 in the world, like in this kind of competitions for like math and computer science.
and then so you spent like I guess your formative years competing in math. Then you moved to the US for Northwestern. What was the biggest culture shock, and how did your thinking shift?
So I actually started like with math competitions, but then at some point I switched to computer science and programming. Informatics is what it's called. Because I liked, if you're doing a math competition, you have to kind of write a solution to a problem and your reasonings of how you got there. And then a human grades your answer. And then when a human grades your answer, like, sometimes I felt like I solved it perfectly and I have like half the points. And sometimes I felt like I almost didn't solve the problem at all. And then I get still half the points. So I felt like the grading of the math problem for the math competitions was somewhat subjective sometimes. And then at the same time, I felt computer science was very, the opposite. Like you just have tests, the computer grades your answer, and you either pass like 80% of the test or 100% of the test. And so I felt like the way you get graded on the computer science problems was more clean and fair. So I actually got excited about this and like spent like, I guess the last 3 grades of high school, like really focusing on computer science and programming competitions. I won like the national Olympiad in my senior year. So like first place in the country. And then the year before, I also kind of represented Bulgaria at the Balkan Olympiad of Informatics, which is like a regional competition, which I got a gold in. And then honestly, like the reason why I came to the US is because my sister, who is 2 years older, she kind of applied and got into a US school. And then my parents were like, wow, look, your sister made it and she got accepted to a US school. She's really happy. You should do it too. And it wasn't my trajectory at the time. I was like happy. I got accepted into like Sofia University, which is like the main, I guess, university in Bulgaria. And But given my sister's experience, I did kind of apply to US schools and got into Northwestern. And then it was like my first, you just come up with the airplane, land, you go to a dorm, and then you start studying in a foreign country in a foreign language. That was a bit of a shock. My English was not that good, and it still isn't. But I really enjoyed the experience. I like the US system in university. I feel it's like probably more applied compared to Bulgaria. Like in Bulgaria, you don't do as much applied work. You kind of study this more theoretical things, where in the US, you just get to kind of do more applied stuff. And the school has much more budget than like a school in Bulgaria. So like you get to do robotics, you get to do, I think, interesting things. So I really like my time at Northwestern.
So take me back to your first real engineering job. What were you working on, and what made you kind of fall in love with the craft?
So I actually did like I worked part-time in Bulgaria at a software company, and I liked the work there. But I think one of the first things I want to mention is I did an internship at a startup in Seattle, actually in Bellevue, called Schoolsoft, and then they later renamed themselves to Dreambox Learning. So it was like an educational startup where we were developing like a product for kids to learn math, like from first to, let's say, fifth grade. And I was like their first intern. There were like 5 people. And I really like that stage of a company. It's so small, essentially 4 engineers and 1 intern, and you get to work on the actual product. Like, they're so small that they can't just give you like some research project that they don't care. They give you like something that they would have done themselves, but they have something higher priority to do. So you have to deliver as well. And sometimes, because it's a startup, like the thing you work initially on doesn't seem like it's going to be that useful. And so like a month in, like you reevaluate and switch to something else. So I thought I kind of fell in love with that mindset that you have to be nimble, you have to change, you have to embrace the change when you work at a startup. So I kind of really like that. And then I did 2 internships at that startup and 1 at Microsoft, and kind of this possibly is why I decided to go and work for kind of startups after school rather than like the big tech companies.
And then you spent 10 years at, what was it, IMO?
Yeah.
Scaling essentially back-end systems to over 200 million monthly users. So what is something about running infrastructure at that scale that you can only learn by doing?
So I want to give you like the whole story. So I was like graduating school. I had like offers from Microsoft and then like some bank in Europe because my girlfriend was in Europe at the time. And then I got an offer from this startup in the Bay Area called IMO. And so I wasn't super sure about the product. We had like a messaging service that you could log into multiple messengers and it will aggregate them into one service. So you could sign up with Skype and MSN and Yahoo and Google, and like it will just give you the list in one place, and you can use it on your browser rather than like individual clients for the different things. So I was not so sure about the product, but I really liked the team. So one of the founders was George Herrick. He's one of the first 7 engineers at Google. Really smart person. He was in charge of Gmail at Google, and he started the AdSense business. So just super smart person, and he and his brother basically started that company. I joined as like engineer number 6 or 7, and I kind of just I really fell in love with the team. The team was, but the questions they interviewed me with, I could sense that they're also fairly smart people. Like the questions are harder than the other companies would have asked. And I wasn't planning, like at school I studied distributed systems, and I maintained, like as a summer job or just like job during the school year, I maintained like a cluster of Dell machines for one professor. And so when I joined IMO, like a few months after that, one of our old engineers who used to set up the servers like left, and so the founder asked, like, who wants to order the next batch of servers for us? And so we were using our own servers at the time, no AWS, no clouds, and so I kind of volunteered, and then this kind of fell into my lap as we grew. So I both got to work really on the backend services for the messenger, but also on the infrastructure. So I help like negotiate the data centers. I help buy the machines and negotiate the internet, buy all the internet connectivity for us. And it was kind of amazing to do this as like our service really scaled. Like at some point we decided to build our own messaging network and abandon like us being just a front end for Skype and Facebook Messenger. And that really helped us. Like we basically really focused down on our own network. We made sure we have very good voice and video calls. And at the time, WhatsApp didn't have voice and video calls. And so we really like took off like a rocket ship as the whole world was basically getting mobile phones. Like imagine like a person in India getting their first essentially Android phone. Before that, they didn't have a desktop computer, they didn't have a laptop, so they didn't have any accounts actually with Skype or MSN or even Facebook. So they would get this new phone, and the friends will tell them, like, if you download this app, you can do a video call with, your friend who is in another city or it's in another country. And we really made sure that the calls worked at the very congested, very poor networks in the developing world. Because like if you wanted to do a video call in the US, you could, just use Skype or Facebook, or the other people's video calls worked in the developed world, but not in the developing. And so it was very interesting 4 years. Like our users would almost double every 6 weeks. And so think about this, like every 6 weeks, you have to kind of have double the servers, almost double the capacity, double the internet. And so I enjoyed this time a lot. Like we had a great team and we built a awesome service that like millions of people would use. And it's also satisfying because I also use it to like call my parents and so on. So I still do.
So are you talking about IMO or the Halo app?
IMO.
Oh, okay. So I was going to ask you, so what going from being like an individual contributor to, director of engineering at IMO, then jumping to a founding team role at Halo app, like what did each of these kind of transitions teach you about yourself?
I think it's all a journey. Like I think having the ability to essentially start deep infra is kind of a consequences of all this kind of decisions. So like working with the team at IMO and building the messenger, the company got acquired. I met like some new people after the acquisition, but ultimately I felt like it's time to do something else. Like it wasn't changing any much. We weren't doing as interesting things at the end before I left. So I got recruited by Niraj Aurora from the WhatsApp team and Michael, who left, I guess, Meta and started like How App. And so I loved the opportunity to kind of try something from the ground up. Ultimately, we tried for a couple of years, but we didn't get as much traction. Sometimes it's despite our best efforts, like the product just didn't stick as well. But you meet people that then help you along the journey, and both Michael and Niraj are investors at Deep Infra, and they're advising me and helping me a lot. And George is very, very kind of instrumental to Deep Infra as well. Like he's an investor and an advisor. So my journey is like you have to, not that you cannot start a company like fresh out of college, but at least in my case, like I really value my experience in the places I worked before and the people I met to kind of get to a point where I felt like now I want to build something. What should we do? Who should we do it with? So that's kind of all. The connections you make in the previous places, the people you meet are really critical to the success of your future venture.
September 2022, you and the crew, right, from Deep, you guys start Deep Infra. You and make it so that people can run ML models cheaper, right? ChatGPT drops like 2 months later. Can you walk me through that moment, like kind of what changed in the room?
So I actually, sometimes forming these companies takes a while. So I've been talking to my co-founders and like early engineers, like all the way since the beginning of 2022, and advisors. So we decided we're gonna like try to build a company with my co-founders, but we were not yet sure like what area should we try to do. We had like 3-4 ideas, but at the end it boiled down to the following, thanks to kind of advice from our advisors as well. Like we felt that the AI is definitely coming. Like even in the summer of 2022 in the spring, there were very interesting open source models that you can see some intelligence in. And yes, they're not as useful as the stuff we have now for sure. Like if you kind of even can't remember back then how like the models were pretty basic. Like you can ask them what's the capital of France, and they can like say that, but you have to ask them the capital of France is, and let them just complete the word. You couldn't ask a question. So that's essentially what ChatGPT did. They basically trained the model to be conversational. Before that, the model was basically a completion model. It could complete a sentence. But so anyway, like I wanted to build something that is going to take our experience from the previous companies and kind of build on top of it. And so we had the experience of building infrastructure pretty cost effectively. And we had relationships with data centers and ISP providers and server manufacturers. And we had a team that built like this API layer. Like if you think about a messenger, you have a mobile app, and then you have a backend. And your backend has to have APIs for your clients to send messages, send photos, make calls. And then you have to make sure these APIs are very reliable. Like if your messenger basically doesn't work like for an hour, then all the customers would just go and switch to WhatsApp or some other messenger. So like building a reliable APIs is like what our team had experience with. So we decided to focus on inference. Like, the other insight I had that I guess it took like 4 years for kind of to become more mainstream is that I think most of the compute is going to get spent during inference rather than training. And it makes sense to me in the following way, right? Like I went to school for like 4 years, 10 years, but then I get to work for 40 years. And the same way, I feel like a model makes sense that it's trained on, let's say, 1 million hours of compute, but then spends 10 million hours of compute kind of doing inference. And the part that was actually, before ChatGPT came out, I would say like 95% or 98% of all compute was just spent training. Like, people kept training better and better models. When they release a model, people would like play with it, but no one really had like a production use case for it as much. So that's the setup. Like I actually left my previous job in April and we formed the company, but we didn't actually start working until September because I felt like I need some time. I worked nonstop for the last 12 years. I was like, let's take like 3 months before we start this because then it's going to be all in. And so in September is when we actually started writing the code and working on it. And it took a while. Back in September, there were still no good open source models. It took kind of almost the next year after ChatGPT came out, like a few months after that, Llama 1, the first kind of good open source model that got released by Meta, that was non-commercial. And so only after the second version of that model came out, the Llama 2, that was kind of commercial, then we started seeing like our fit, our go-to-market fit. Basically, the number of tokens that we would generate every day kept kind of increasing exponentially. And that's kind of where the scaling journey began.
You've said that inference, I guess, would become kind of this dominant driver, right, of enterprise AI workloads. When did that conviction like crystallize, and who told you were wrong?
I don't think anyone really told us we're wrong, but like it's also at the time when we started the company, we're like, let's focus on inference. But essentially, at the time, like 90+% of the compute and effort went into like training. So just like not as high interest from, I guess, customers, or it was kind of a bit early in some sense. Like not everybody was as convinced about inferences people are now.
And the first version of Deep Infra was about CPU inference, right, for trained models. And then the pivot to kind of large language models on GPUs is kind of a different business, right? So what was the trigger that made you change direction?
So I want to correct here, like from the very beginning, we were focused on like GPU inference. And it's mostly just because like the models were all trained on GPUs for a reason. Like the GPUs has the high quantity of math it can do and the bandwidth. So from the very beginning, we were doing most of our inference on GPUs. But one mistake we made is when we were first starting, we're like, we want to host models. We want to be a hosting platform. And we were like, our goal was, let's make a hosting platform that can host the top 100 models on Hugging Face. But at the time, I think the top 100 models on Hugging Face were all old models, like BERT, and they're not like the future. They're like an older version. So I think that's a bit of a mistake we made. Honestly, the first 6 months, we could have focused on not the top models, but like the latest models coming out. And it's a learning period. Like, this industry is changing so rapidly that it's not easy to catch up with like all the latest changes. But like, that's where the first version of the platform we built, we could host the top 100 models on Hugging Face. They were just not as interesting to customers as the new models coming out. And so we then just focused on things like Llama and then Mistral, and then the newest models coming out, and we just put our attention into them.
Got it. And then 5 to 10 times cheaper, right, than OpenAI and Anthropic on equivalent workloads. Was that a pricing decision, an engineering decision, or both?
Um, honestly, from the very moment we were starting the company, back then, by the way, OpenAI was measuring like their pricing was in thousands of tokens instead of millions. And so the first like big model we priced was like Llama, and we said like this model is going to be $1 per million tokens, and it was kind of an aggressive price at the time. Now prices have gone down even more because we just got so efficient at running these models compared to like 3 years ago. So look, it's kind of a bet, right? There's got to be either closed source or open source model. So from the very beginning, for deep infra to be successful, we had to bet on open source models. Because if we're only going to have closed source models, then they're all going to be run by Anthropic and Google and OpenAI, and they wouldn't use like a third party people as much. They just like develop all this technology in-house. So our bet was, let's hope there's good open source models and let's make sure we can run them efficiently. And just the way it works out at the end is there are great open source models that we could run and sell tokens at prices that are 5 to 10 times cheaper than Anthropic. And then we were kind of lucky, or like placed the right bet, and the open source models have really closed the gap in terms of quality. The best models are still the top closed source models, so like no doubt about that. Like, but the open source models are like 5% worse in terms of intelligence benchmarks, but then you get more control, right? Like you can use us to run them in our infrastructure, but you're kind of in control. If you want, you can always like run it yourself and bring it in-house. And companies like this flexibility, including like we as a company, we like using Linux, right? Because it's kind of not owned by anyone. You can move it around. We like using like open source tools like Grafana and open source databases like Redis, because they're kind of these tools that you could control and own. And so for the same reason, I feel like companies like using open source models, given the right choice.
So 8,000 times growth in tokens processed since 2022. What broke first, and how did you fix it without taking the platform down?
Oh, I mean, many things we had to like engineer along the way. But by the way, this is exactly the experience we had from the Messenger. Like, I want to again highlight that story for a moment. Like, me and my co-founder Georgios, we wrote like the first version of our messaging protocol for IMO. And before that, we would basically connect to Meta or Google and their servers and just forward the messages to them, and they'll forward the messages back. But this was the first time we implemented our own. And so we saw this thing scale from basically 0 users to 200 million users. And we had to, almost every order of magnitude, you have to kind of redo the design and change it. And you have to do it without interrupting the service. So you kind of like plan for something and migrate the users and kind of get them to the new system without them seeing anything changing on the back end. So I think similar things, like we had to scale our GPU capacity, find more data centers, get more servers. I think getting the chips is not easy, as maybe a lot of your viewers know. Then on the software side, there's many things you have to scale, like front-end servers, API servers, databases. You have to keep increasing their capacity or splitting them up into smaller chunks so that you can scale it up. Also making sure like our inference runs when there's multiple data centers involved, right? That's another challenge. But I love all of these problems. Like this is kind of what we operated at the Messenger. Like we had 200 million users worldwide calling each other. Like, and then we had thousands of servers around the world that would route these calls and make sure it works well. So there were, few issues along the way, and generally, I wish the service is even more stable. But AI is very compute intensive, so you just need million times more computational power than like traditional things. I'll give you a very quick example. Like if you have a model that's 100 billion parameters, which is typical these days, generating one token out of it, one word, takes 100 billion mathematical operations. While if you have a database and you fetch like one row out of the database, let's say like you ask like what's customer 777's name, that's kind of also one word coming out of the database, but it only takes like 1,000 to 10,000 CPU instructions. So the models are like million times more intensive than our previous kind of things that we did. And that's why there's all this demand for data centers. There's all this demand for chips, and not just GPUs, but disks and CPUs and memory, and almost everything is like in a shortage. But also, I think we've discovered this technology that's so useful that it really changes like how we do everything. Like I was a really good software engineer, but I don't see me writing any code anymore. It's kind of just interacting with an agents. And so that's kind of a crazy shift, right? Imagine you're a surgeon and you're accustomed to every day going to work and like, doing surgeries, and now you're basically no longer going to touch a scalpel in some way. And so like we're living in a really revolutionary times. Like the last year especially is, I guess, the craziest year ever.
Ever. Yeah, that's for sure. So Deep Infra processes nearly 5 trillion tokens per week. Most people have no intuition for that number. Can you translate it for them? Like, what does 5 trillion tokens actually do?
Well, I don't know how else to say it other than a lot of tokens. Like when we first kind of attracted interest from bigger investors, we were doing like something on the order of 5 million tokens a day. So it has grown almost a million times. It's both a large number, but also a very small number, to be honest, because the amount of inference I think we will need to do over the next 2 years is probably at least 100 times more. So we're still in the very early stages of this whole adoption of AI process. Yes, many of us are using it, but not to the extent that we would be using it in 2 years. So it takes a lot of effort to get to here. It takes a lot of compute resources, a lot of investments. We've raised 130 plus million total in like VC funding and some debt as well. And we've kind of invested all of this into this inference clusters. It's really like a factory, right? That's why Jensen likes to talk about this. Is like AI factory, token factory. Like the machines that NVIDIA sells are like the machines that help you generate the tokens, and then you need to build factories out of them and use them efficiently is the other key thing. Like you want to make sure your machines are always generating tokens close to their full capacity.
And roughly like what 30% of your weekly volume now comes from agents, right? And not humans. How does serving agents change everything about, how you design the platform?
I think the one really important thing for the agents is you have to kind of understand how they work. So basically, an agent would keep sending roughly the same request with a little bit of extra information at the bottom. So think about it like you give it a problem and then you ask the agent, like, help me solve this. The agent will come back and say, this is one inference request. So the agent, asks our model, we return a result, and the result is like, the agent wants to call some tool. He wants to read some file. He wants to make an internet like search or something. And then once that is done, let's say you do the search or you keep the file, and you make the same request again, like it's the same context comes back to us. And just you have to, given this new information, the question is always, given this new information, what should we do next? That's always the loop. Like the agent basically keeps going in a loop and saying like, what should I do next? It comes up with like one thing it wants to do, it does it, and then it goes again. Like, given all this data now, what should I do next? So what you see is the same data goes, the same context comes to us many, many times. And so being really efficient in kind of storing this context and continuing the conversation from somewhere, what's really key for the agent. So we're one of the first people to add like cache token pricing on Open Router for open source models. And we really like delve deep into that. Like this lowers the cost another almost order of magnitude because the cache tokens are essentially not that expensive. And like a good models now are basically in the 5 to 10 cents for like cache token pricing. Well, the real input tokens cost like dollars. And so that's really the important part. That's why inference is kind of this complex problem. Like for lack of better words, you have a factory, but if you're gonna essentially make another unit of for the same customer, you want to have the machine really warm to be able to produce that unit without spending math to like recompute the context for that user. So that's, I think, what's really important for agents, like that caching, that efficiency on the context. The other thing that agents really like is this super long context, right? Like as a human, rarely you like ask the model and you pass like 100,000, I don't know, words. You kind of have smaller questions, but basically agents have very large context. So being really good at long context and caching is like key to having good efficiency.
So NVIDIA co-invested in your Series B, and you're an early collaborator on Dynamo and Nematron, right? So how do you stay strategically neutral when the dominant kind of like hardware vendor is on your cap table?
That's a good question. Look, before NVIDIA invested, first I want to say that as a company, they're really nice people and really friendly people. They're the largest company, but when you kind of interact with them internally, they feel like a much smaller, much more friendlier company, much, even when, imagine this, right? Like we're 20 people, right? And they're like this largest company by capitalization. It doesn't feel like they always value like whatever we want to say or whatever we want to share. So that's kind of how the relationship with them started. Like we see a lot of tokens flowing through our services, flowing through their latest chips, and we see, I guess, issues, crashes, problems, and we like to share all of this with them because we would like to fix it, and they also are really incentivized. They want to fix this for not just us but like the broader base of customers, right? So and they want to make sure that their chips are really efficient at inference, right? Like if you think of what's, I think, on top of mind for NVIDIA is they want to make sure when they do a benchmark using like the latest generation NVIDIA chip and the right software, it can make more tokens than a competitor's chip with their software. Because that essentially is the real, I guess, like thing that a buyer would look for, right? In a factory equipment, like how many tokens can you make in an hour versus how much it costs. So that's kind of how the relationship started. I think sometimes you just get lucky and you get to work with like the right account people, just the right team, and then the relationship grew and grew. We love kind of helping as much as we can NVIDIA when they want to ship an open source model that they've trained, like Nemotron. I think strategically we have good open source models, but a lot of them are built in China. And this is not the best for deep infra. Like we would like to have more US-based open source models because some of our customers are concerned. And even though we run the inference and we store nothing and nothing gets sent anywhere, so it's very private, no matter if the model is Chinese or not. It would be nice to have US kind of trained good open source models. And so NVIDIA is like really kind of investing in this, really trying to kind of build and give this to the world like a good open source models that they're building in the US. So we want to help as much as we can. So we kind of help make them available to customers. We try to work together on ironing out any early kind of kinks around them and making sure the performance is great. So that's another area where we like to collaborate with NVIDIA. Now, at the moment, I feel like their chips are still like the most efficient at inference in terms of like you buying an asset and having it in your data center for 5+ years. Like they're, I think, like a safe, efficient choice right now. Obviously, the same way I feel like if inference is going to be so large and so important, a bunch of companies are obviously trying to build chips that are going to be good at inference. And so we'll see how that goes. I think, we're well positioned to use the most efficient technology to generate tokens. But at the moment, like we've mostly invested in essentially NVIDIA chips on which we run the tokens.
Hey Nicola, wow, this has been such a fascinating interview. Help me land the plane, right? So if you fast forward maybe to 2030 and deep infra has done everything you hope, like what does the world look like that would not have existed without you?
Great question. I think my hope for 2030 is of all the tokens in the world produced, like 70% come from open source AI models or some modified versions of them. In my view, like 2030, we want to have token factories in many places around the world. Currently, like a lot of our capacity is US centered, but I think tokens would be needed like all around the world. So we want to have compute capacity, compute inference clusters spread around the world. And we really believe in driving the cost down per token. We feel like that's going to be really important for agents running in the background. Like while humans still interact a lot with the agents, I think like the speed of the inference matters. So you have to kind of make something fast and essentially pay more per token. But I think as we go towards like more background work that we trust that agent is going to do the right thing, I think the efficiency is going to be in like lowering down the cost. And this makes like certain things that we couldn't have done before like possible. So I want to keep kind of making sure companies all around the world, startups, medium-sized enterprises have access to reasonably priced tokens running on the most efficient chips all around the world. That's kind of what I want to get in 2030.
Cool. I like that. Awesome. Well, thank you. I see we have almost 25 people, 24 people synced in and listening to us. Thank you all for tuning in. Nicola, thanks again for your time. Just hang back for maybe 1 second. I'll bring this stream to an end. Until next time, everyone.